Okay, in this video we're going to begin to talk about, or we will talk about, problem type number 6. In the first example, Barry's walkie-talkie has a range of 2 miles. And these are all absolute value problems. And remember, with absolute value problems, what we're interested in is absolute value of x minus the center is equal to the distance from the center. And what we have here, this range of 2 miles, that means it can, the sound of the walkie-talkie or the reception of the walkie-talkie can be received or sent out for 2 miles. And that's going to be our distance from the center. Barry with the walkie-talkie, he's the center. The signal is going out and coming in from up to 2 miles away. So if you want to think about that, here's Barry. And we know that his signal is going to be able to go out up to 2 miles away. So Barry is traveling on a straight highway and is at mile marker 207. So where's Barry? Barry's right there. We want to write and solve an absolute value equation to find the maximum and minimum mile markers from 207. Well, we know if we go down 2, we'll be at 205. If we go up 2, we'll be at 209. So our equation for this is going to be absolute value x minus the center equals the distance from the center. We know how to solve this, and when we solve it, we should be getting the values 205 and 209. We set up one equation, x minus 207 equals 2. Another, x minus 207 is equal to negative 2. We add 207 to both sides. And when we do, we get x is equal to 209, which we expected. Add 207 to both sides. And we get x is equal to 205, our second anticipated answer. All right, problem number 15. A quality control inspector at a bolt factory examines random bolts that come off the assembly line. Any bolt whose diameter is not between 6.46 and 6.54 millimeters is sent back. Write and solve an absolute value equation that gives these maximum and minimum diameters of an acceptable bolt. So what we're given in this particular situation is not the center and the distance from the center as in the previous problem. What we're given here are the two endpoints. 6.46, 6.54. And we need to calculate both the center and the distance from the center. How do we calculate the center? We just take the average of the two endpoints. So we'd have 6.46 plus 6.54 divided by 2. And so we have 6.46 plus 6.54 is equal to 13. And 13 divided by 2 is going to be 6.5. What is 6.5? 6.5 is our center. Now what we need to figure out is the distance from the center. And we can calculate that as well by doing 6.54 minus 6.5. We get 0.04. We could also do 6.5 minus 6.46. That would give us 0.04 as well. So we know we have our distance from the center being 0.04, at which point now we can set up the equation, which is absolute value x minus the center is equal to the distance from the center. and we solve it as we did in the previous example, setting up two equations, we're going to get, or we should get, if we execute it correctly, 6.46 and 6.54. We'll go on to the third example in this set. Number 16, a machine prints posters and then trims them to the correct size. The equation absolute value of x minus 65.1 is equal to 0.2 gives us the maximum and minimum acceptable lengths for the posters in inches. Does a poster with a length of 64.8 inches fall within the acceptable range? Why or why not? So we can do this two ways again. We have our equation, which would be x, absolute value of x minus 65.1 is equal to 0.2. We set up two equations. X minus 65.1 equals 0.2. X minus 65.1 is equal to negative 0.2. We add 65.1 to both sides, and we'll get x is equal to 65.3 on one side, add 65.1 to both sides of the second equation, and we'll get x is equal to negative, clear that, negative 0.2 plus 65.1. We end up with 64.9. What are those values? Those values are our endpoints. And so if we were to graph them, we would have 64.9, 65.3 with 65.1 as the center and 0.2 as the distance from the center. And so the question is, does a poster with a length of 64.8 inches fall within the acceptable range? And we say no, it is not acceptable because it is too far from the center. All right, we'll have another couple of examples here. In a cheerleading competition, the minimum length of a routine is 4 minutes. So we can right away set up 4 minutes. The maximum length of the routine, 5 minutes. Write an absolute value equation that represents the minimum and maximum lengths. So what we're missing here is the center and the distance from the center. We're going to add the two endpoints. Divide by 2 to find their average, and we're going to get 4.5, which is our center. Then we can tell that the distance from the center is 0.5, and we put it all together. Absolute value of x minus the center is equal to the distance from the center. And that's all we'd have to do in this particular case, set up the absolute value equation. Next. Okay, and problem number 7, which is also from the picture packet. We have a poetry contest. The minimum length is 16. The maximum length is 32. So if we were to make a number line, 16, 32, what we need to do is to find the center and the distance from the center. We would average the two. 16 plus 32 divided by 2. That's 48 over 2, which is 24. So our center is 24. Then our distance from the center is going to be 8 on each side. And finally, to write the equation, it's simply x minus the center is equal to the distance from the center. And that gives us our equation for problem number 7. Problem number 26, also from the page 6 of the picture packet. We have the two, the minimum and the maximum lengths of shoulder heights for miniature poodles. So we're going to set up our number line. We go from 10, to 15. We would have to average those two. 10 plus 15, which is 25 over 2, or 12.5, would give us our center. Distance from the center would be 2.5. And so we want to write an equation. Absolute value of x minus the center is equal to the distance from the center. Again, in this case, we're given the endpoints. We need to calculate the center, calculate the distance from the center, and then to construct the equation. I believe we have one more example here. Okay, in this problem, number 48, the recommended weight of a soccer ball is 430 grams. So that's one value. That's the recommended weight. That's going to be the center. So in this case, we're given the center. The actual weight is allowed to vary by up to 20 grams. So what we have there is a distance from the center. We should be able to calculate fairly easily. We can go up to 450 or down to 410. And we want to write and solve the absolute value equation. X minus the center is equal to the distance from the center. Again, if we were to solve that out, we would get two equations. X minus 430 equals 20, and x minus 430 equals negative 20. Adding 430 to both sides, we end up with x is equal to 450, which we expected. Adding 430 to both sides, and we're going to get x is equal to 410. So 450 and 410, which we can see in our diagram, in our graph above. Now, part B, a soccer ball weighs 423 grams. Due to wear and tear, the weight of the ball decreases by 16 grams. Is the weight acceptable? Explain. So, since 416, it decreases. It was 423. So, 423 minus 16 now gives us a weight of 407. And we just say this is outside of the acceptable range. And so that's it. It has to be in between 410 and 450. So that'll do it for problem type number 6 in this video.